Hello and welcome back. Today we have a turntable. So $50, parts, bad motor is what I bought it with. Some Modular Component Systems, a JCPenney branded turntable from I think late 70s, 80s, throughout that time. Whenever JCPenney was around, I suppose. So these were all made by Technics at the time. So this is a clone of a Technics turntable. And another issue is that the hinges are messed up, or at least one of them is. So we can see that left one is all broken off on the acrylic. So I'll have to address that. And then around back here, we can see where the hinge is attached to the chassis itself. The one on the left is good, but then, yeah, that one's all broken off. So we got some work ahead of us trying to fix that. So something I'm curious about, I don't know a lot about turntables or vintage ones, or basically the first one I've picked up, honestly. So I don't know if $50 is a good price or not. I don't know if I overpaid for this. I'm kind of curious if anyone thinks this is a good deal or a bad deal. All right, so yeah, you can see when I moved that arm, nothing turned. It didn't matter what speed I had it on. So we have something going on. So the store that I bought it from said that when they got it in, they put a new belt on it, and it didn't work, so they just assumed it was a bad motor. So I took the belt off, took the platter off, and just put some tape on there, see if it'll turn with no weight on the platter, and yeah, still nothing. So just gotta flip this thing over so we can take the bottom off and start troubleshooting. Pretty simple to take off. Just I think 6 screws on the bottom hold this down, and then you can just pop it off. And they're pretty bare bones inside. Not a whole lot going on. This one is a semi-automatic turntable, so it won't automatically start, but it will automatically return back to its home position when it detects that the record's over, or when it reaches the end of the record. And something that stood out to me pretty fast is this wire was just hanging loose. I don't know exactly what it does, but yeah, it's just something that could be wrong. And yeah, should have locked that back down. Luckily I didn't bend the stylus. And yeah, so right now I'm just taking the motor off so I can mess with it, and I can see if the motor's turning from the other side. And look at that, 7th June 78. So I assume that's a date code for the motor itself, or the servo motor, so pretty old machine. And I did find the service manual, so I can start doing some troubleshooting. The service manual is pretty terrible with this machine. So looking at the output voltage of this board, it says 13.3 volts. And on the troubleshooting guide, we see here, switching on does not cause turntable to rotate. Possible cause, output of constant voltage circuit is 9.6 to 14.4 volts. I don't know if I'm reading that wrong, so apparently there's something wrong with this board. But yeah, it doesn't say what it should be at, it just says that it shouldn't be at that. Maybe that means there shouldn't be alternating current coming out of that, but I really don't know. So I'm just soldering on these wires onto the input where that 13.3 volts is coming off, and I'm going to attach this to a power supply and just put voltage on it and see what happens, because if I'm reading that right, then that constant voltage output board is not putting out the correct voltage. So let's see what voltage it needs in order to run. And honestly, I just want an excuse to use this power supply that I just picked up as well. So we can see I have it at above 14 volts, and yeah, 16 volts there, and nothing, no spinning on the motor. And it's not until I get the voltage up really high, kind of scary high actually, until it starts to turn. Yeah, 24 volts. So I don't know if that thing's supposed to be running at 24 volts. That doesn't seem right, but what do I know? But at the very least, this confirms that the motor isn't actually bad. which is good because I don't know how it would replace that motor and like have it fit. And then something else I read is that the speed selector switch is defective, so bad contacts or bad solder. So I thought that was worth investigating. So we got to pop off the switch here. It's kind of a weird switch, just a really big rotary switch for 3 positions. And then, yeah, really quite simple to take this off. Don't mind that, just the motor smashing on the bottom of the record player. So here I'm testing the continuity of the switch to make sure it is not passing current when it shouldn't be, and it's passing current when it should be. So yeah, you can see it's working correctly. Nothing was passing when it was on the off position. And then, yeah, that's also the same for the obverse side. But I thought, well, why not? It's pretty exposed there, so let's spray some contact cleaner in it, twist it around a bit. So I did this for quite a while. I think every three rinses worth of contact cleaner I gave it. Just kept turning it. And it really did start to spin a lot more freely. So here I'm switching that arm, and yeah, look at that, motor spinning. That really surprised me. I was not expecting just cleaning the contacts to completely fix this, or at least apparently fix this thing. So just put the motor back where it should be. So it's always, yeah, it just goes to show it's always worthwhile cleaning the contacts on these machines. I don't know if it was just too much resistance for that board to turn the motor. I don't really know. I don't know how servo motors work very well. So I'm putting that switch back on. And let's get that platter back on. See if it'll turn the platter. And not quite. Needs a little help. So it's still not fully fixed yet. Just needs a, yeah, there's still something holding it up. And I kind of remember that there is this pitch to modify the speed of the turntable, so I bet that was also really corroded inside and causing a lot of resistance and slowing down the motor. So again, really simple to take apart. Just pop the cap off and then just unbolt it. A little harder to clean this one. It's one of those enclosed potentiometers instead of just a contact switch like the previous one. But get some contact cleaner in there and twist it around. Did this for quite a while. And yeah, there you go. Now it's working pretty well flawless. And the auto return even works. And automatically shuts off. Yeah, everything's working fine. That was a very easy fix. So put a test record on it. Make sure that stylus is working, the cartridge is working. And yeah, we got music. This really is a nice looking turntable. And automatic return. Alrighty, so now it's time to figure out this broken hinge problem. So the plan is to take this apart, and you can see it's staked or pinned or something. No real easy way to take it apart. So the only way I know to do it is to just drill out the pin, because it's all peened over. And please ignore the horribly sketchy vise I have with just 2 clamps. So yeah, just using little progressively bigger drill bits to take out the end of this pin, and then I can remove it. And I'm removing it so that I can take measurements on it and then 3D print a replacement for the other side. Since this is the good one still, I could probably have got the sizing on it with it still in the hinge, but it would have been significantly harder. So a little tricky to get out. Definitely not designed to be easily removable, but yeah, I got it out. So we can see here it has a coil spring built into it, and that's how it's applying the torsion in order to hold the lid open when you open it. So yeah, it's gonna be a bit of work getting that modeled, but hey, look at that, it's modeled. This is actually probably the most complicated thing I've ever modeled. I have no formal training on using modeling software, so I was very proud of making that. And I decided to use the resin printer. It's a pretty precise object, at least I thought it was, and resin printers should be strong enough. And yeah, if you've ever seen one of how these what do they call them, lithographic printers, something like that, how they work, they're really cool. How they just pull the finished product right out of the liquid resin. And that's it. Not quite done, but at least done printing. So you can see they're all still covered in the liquid resin, so you have to clean that off using isopropyl. They sell, machines that'll wash them and cure them for you, but I prefer kitchen cup and bottle of alcohol. So let that soak for a while, mix it around, and let it dry it, and yeah, that cleaned it pretty well. And then you have to, once it's done with this, you need to finish curing them. And like I said, they have cure stations that come with these printers. I prefer just sticking them in the sun, and that'll cure them fast enough. So, and I ended up printing just a ton of them, because why not? So, here we have the original. And here we have the 3D printed one. So I only had to do a slight modification to it to get it to work correctly, which was very nice. I didn't have to redesign anything on it. And you can see I've upgraded. I got an actual mini vise now instead of just clamps on clamps. So pretty tight fit to get that spring in there, but it fits. And I'm just reusing the cap, since that was still good on both of the hinges. And instead of a pin, I'm just using a screw, and just not tightening it very tight, but just getting it snug. And yeah, seems to work pretty well. Quite a bit of spring force on that. And yeah, fits perfectly onto the hinge. So now it's time to deal with the other one. So the approach I took was to just completely remove what remained of this on the acrylic case, and then just replace it with a 3D printed imitation of it. So I put a bunch of painter's tape around the acrylic to protect it from the file, and that actually did a pretty good job. I had to keep adding more layers of it because I was just tearing through it too fast. And yeah, we have that little piece of the hinge completely removed. I kept the damage down minimally, I think. And then there was also this crack on it, so got to try to glue that up so it doesn't get any worse. So I'm putting some tape around it so I don't get the glue too many places I shouldn't. And I'm using this Loctite like clear construction adhesive. It was the closest thing I could find to like an acrylic glue in my local hardware store. So I'm just slathering that all over the crack, getting it inside, and then just wiping off the extra. And it is definitely some clear glue. And yeah, there's the 3D printed replacement. So just design that in same program. So I'll need to glue that to the acrylic, and then should be good to go. So I got to figure out where exactly to put it on the acrylic. And no, it doesn't fit at all. Probably help if it's the right way around. And still not great. It's leaning away quite a ways. Still see where it's gonna go though. Yeah, it's just no good. So, gotta do some modifications to that. So removing this this side so that it sits deeper into the chassis receptacle thingy, whatever you'd call it. And that helped a little bit, but you can still see there's a bit of a gap. So I'm trying to thin it out on the bottom, and I rounded off the back too. And that got to fit a lot better. So here I'm just gluing it down. So I'm using that same clear construction adhesive Loctite. And this is a day later, and yeah, pretty solid. Should be good to go. So I've got to line up both of these hinges. And putting it down. And the glue didn't hold at all. So not the best glue for acrylic, so next best thing is use some epoxy, right? So the plan here was to just coat the whole thing in epoxy and just kind of suspend it, because there was a bit of a gap that it still wanted. So got that glue kind of piled up, or the epoxy piled up on that little section. And I've removed the springs from the hinges here so it'll stay where you put it. And you can see that gap still, but I figured the epoxy can bridge that pretty well and just completely encase the top parts of those hinges. So yeah, it doesn't look too bad, I guess. And then another issue I ran into is because I printed it on the resin printer, I didn't realize how brittle that resin is, and it kept just exploding these. When I would lean it forward, they would just crack apart. So that was one broken one. Here's another broken one, and they all failed in the same spot. Just too much upward force on that. So I did end up printing it just on the regular filament printer, and it printed just fine actually. So I should have just done that from the start. That filament printer is a lot easier to use. It's a little bit of a tighter fit, but it's still pretty good. All right, time to clean this a bit. So overall, the acrylic wasn't that bad. It has not gouges. It definitely has 40 years of scratches in it. So I don't know if any good acrylic polishes. I was looking at reviews of stuff online. I didn't find anything that I trusted. Everything was like either a 1-star or a 5-star. So if anyone knows of a really good acrylic polish, I would definitely try that on it. Just buff it up a bit. And yeah, not too dirty at all. This was kept in a pretty clean spot. Just some general dust and dirt, but it's shined up really well. Not too filthy. And clean that platter a little bit. Which again, wasn't... Oh, it probably didn't need to be cleaned. It was pretty well spotless. So let's get these knobs back on. And getting some glue on the spindle, or not glue, oil on the spindle. I don't know if it's necessary, but I'm sure it can't hurt. And yes, I did forget to put the belt on. All right. And there we go. All put back together. So yeah, let's give it a test and listen to some music. All right, so I'm filming this as a bit of an addendum to the prior clip because, and I'm sure many of you predicted this, the prior fix of just epoxying the hinge to the door did not work. Or I should say, it did not last. I want to say within 10 minutes of filming the previous clip, I had it sitting on the counter, heard a loud snap, and sure enough, the hinge had completely separated from the acrylic. And that happening at the same time caused the other hinge, which I thought was good, to crack and break off. So I almost just gave up because I did not feel like messing around with this anymore. But I don't think I would have been able to sleep at night, not having completely finished something to the greatest extent of my will. And because of that, I did what I really should have done from the beginning, and I've modified the design of the hinges in order to mechanically fasten them to the acrylic. So we can see I extended it a bit. I removed that little lip thing that existed there and then had holes in it. And then I printed this on the regular, like, Cartesian filament 3D printer. And I did this to both sides. And so, yes, I did have to file down the remains of that other hinge on this side. But that really worked well. It's very solid on this now. And it's so much smoother too. I feel a lot better about this fix than the epoxy one. I don't really know why I avoided doing this from the start. Yeah, I don't know, but and then also throughout all of me messing with this lid, the crack started spreading around to the back, and so I did end up drilling a little hole. It's 1/16 inch hole right at the edge of where the crack was, so hopefully that should stop it from spreading any further. And yeah, so that is where this actually ended up with. So if you thought that the epoxy was not going to hold up, you were definitely correct, because it did not. So I thank you for watching. Have a nice day.